Welcome to Premath. In this video, we have got this triangle ADC along with this segment AB, and as a result, we get these angles 15 degrees and 45 degrees. And moreover, this side length AC is 2 units. And furthermore, this segment BC is equal to this segment BD. And now our task is to find the length of this segment AB. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. Before we proceed any further, let me go over the basic concepts. Let's recall exterior angle theorem. According to this theorem, the exterior angle of a triangle is equal to the sum of two opposite interior angles. As you can see in this diagram, we can see that this angle C is our exterior angle, and that is going to be equal to the sum of these two opposite interior angles A plus B. And now let me give you an example. This angle outside is going to be our exterior angle, and that is going to be equal to the sum of these two interior angles. That is going to be 50 degrees plus 60 degrees is going to be equal to 110 degrees. And now let's recall the 30, 60, 90 special triangle, as you can see over here. And now we can see that 30 degrees is our smallest angle, so the side opposite to that angle is going to be our smallest leg, whereas this 90 degree angle is our largest angle, so the side opposite to that is going to be largest side. So in such kind of special 30, 60, 90 triangle, the longest leg is twice the smallest leg. If the smallest leg is 1 unit, then the largest leg is going to be 2 units, and this third leg is going to be square root of 3. So therefore, in general, if the smallest leg is A, then largest leg is going to be 2 times A, and this third leg is going to be A times square root of 3. And now let's recall this 45, 90 degrees special triangle. We can see this angle is 45 degrees, this angle is 45 degrees, and this is our 90 degree angle. Then such kind of triangle is called an isosceles triangle. So therefore, this side length is going to be equal to this side length. If this side length is A units, then this side length has got to be A units as well. And now let's focus on this triangle. This is an isosceles triangle, since this side length equal to this side length. So therefore, the angle opposite to this side is going to be congruent to the angle opposite to this other side. In other words, in this isosceles triangle, these two angles are congruent. And here's our action plan. Since we are interested in calculating the side AB, and we know this side length AC is 2. So therefore, we are very much interested in this triangle ABC, and we are going to calculate these angles BAC and this angle ACB as well. And here's our very first step. Let's focus on this triangle ABD. And now let's recall once again the exterior angle theorem. The exterior angle of a triangle is equal to the sum of two opposite interior angles, as you can see in this diagram. And we can see in our case this 45 degrees is our exterior angle, and these two angles, this angle and this angle, are going to be opposite interior angles. So therefore, we conclude that this angle has got to be 30 degrees, such that if we add these two interior angles, they add up to 45 degrees. And here in this next step, I have dropped this perpendicular CE on this line AD. And as a result, we got this right triangle CED. And now let's focus on this right triangle CED. We know this angle is 30 degrees, this angle is 90 degrees. So therefore, this angle has got to be 60 degrees. So therefore, we can see that this is our special 30, 60, 90 triangle. And here I have copied down this triangle CED. So therefore, in such kind of 30, 60, 90 triangle, this longest leg is going to be twice the smallest leg. And we know in this triangle CED, since this side length equal to this side length, if I call this side length 1 and this is 1, then this side length is going to be CE is going to be 1. In other words, this side length CB is going to be equal to this side length CE. If these side lengths are congruent, then this is going to be congruent as well. And here in this next step, I have connected these points E and B. And as a result, we got this triangle BEC. And now let's focus on this triangle BEC. And we can see that this is an isosceles triangle since this side length equal to this side length. So therefore, as a result, this angle has got to be equal to this angle. So therefore, we conclude that this angle CEB is going to be 60 degrees and this angle CBE is going to be 60 degrees as well. And the sum of these three angles is going to be 180 degrees, 60 degrees, plus 60 degrees, plus 60 degrees. And since all these three angles are congruent, so therefore this is an equilateral triangle. So therefore we conclude that all these side lengths CE, CB and EB are congruent as well. And now let's make an observation. We can see that this angle is 45 degrees and this whole angle is 60 degrees. So therefore this remaining tiny angle has got to be 15 degrees. And now let's focus on this triangle AEB. And we can see that this is an isosceles triangle since this angle is 15 degrees and this angle is 15 degrees as well. So therefore we conclude that this side length AE is going to be equal to this side length EB. And here's our next step. Let's focus on this right triangle AEC. And we can see that this is an isosceles triangle since this side length equal to this side length. So therefore we conclude that this angle EAC is going to be 45 degrees and this angle ECA is going to be 45 degrees as well. And now let's make an observation. We can see that this whole angle is 45 degrees and this angle is 15 degrees. So therefore we conclude that this remaining angle is going to be 30 degrees. And furthermore, this angle ACB, this whole angle is going to be 45 degrees plus 65 degrees. That is going to make 105 degrees. So therefore we conclude in this triangle ABC, this angle is 30 degrees and this angle turns out to be 105 degrees. And now let's focus on this triangle ABC. I have copied it down over here and we can see our angle ABC is 45 degrees. Our angle BAC is 30 degrees and finally our angle ACB is 105 degrees and this side length AC is 2 units. And now we are going to calculate this side length AB. And here I have dropped a perpendicular CF on this side AB. And as a result, we got these two right triangles, AFC, and this other triangle BFC. And now let's make an observation. We can see in this right triangle AFC, if this angle is 30 degrees, this angle is 90 degrees. So therefore, this angle has got to be 60 degrees. And likewise, in this other right triangle BFC, If this angle is 45 degrees, this angle is 90 degrees. So therefore this angle has got to be 45 degrees as well. And let's focus once again on this right triangle AFC, and we can see that this is our 30, 60, 90 special triangle. And we can see this is our largest leg, and this is our smallest leg. And we know the largest leg is twice the smallest leg. If this is 2 units, then this smallest leg CF has got to be 1 unit. And this third leg AF must be equal to square root of 3. So therefore we conclude that our this segment AF turns out to be square root of 3, and this segment CF is 1. And finally, let's focus on this triangle BFC. And we can see that this is an isosceles triangle, since this is 45 degrees and this is 45 degrees as well. So therefore its side length BF must be equal to this side length CF. So therefore if this side length is 1, then this BF side length is going to be 1 unit as well. So therefore we can see that our this segment AF is square root of 3, and this segment FB is 1. So therefore this whole side length AB has got to be 1 plus square root of 3. So thus our AB length turns out to be 1 plus square root of 3 units, and that could also be written as 2.73 units as well. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.